Hey everyone. Let's put this old phone back in service with the new Generate Background feature in Photoshop. First, we'll remove the background. Then click Generate Background. 1970s New York Street. That does it. With new generative... Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a pretty easy and popular question, invert binary search tree. So all they tell us to do is invert a binary tree. And what exactly does that mean? So let's say that this is our initial tree. To invert it is basically what you can tell in the output, right? So the root stayed the same, but you can see its two children, which were left child 2, right child 7, were swapped, right? So 7 is now on the other side, 2 has been moved, right? So basically we took these and then we swapped them. And when they say invert the binary tree, it's a recursive definition. So take a look at this subtree, right? You can see since we moved it to this side, that's where it is, right? But notice how even these subtrees are different now, right? 1 was initially on the left and 3 was initially on the right, but now 3 is on the left and 1 is on the right. The exact same thing happened with this tree, right? It was moved over here to the left side, but then its children were also swapped, right? So 9 was moved to the left, 6 to the right. So when they say invert the binary tree, what we're saying is visit every single node in the tree, right? And every time we visit a node, take a look at its two children and swap the positions of the children, right? So in other words, if we're given a tree, look at the root node and take its children and then swap the positions and then recursively run invert tree on the left subtree and run invert on the right subtree. So it's a recursive definition. So we can solve this problem with recursion. We can do a depth first search, whether it's pre-order or post-order, it doesn't actually matter. A depth first search will allow us to solve this problem recursively. So this problem would probably be a lot more annoying if it were iterative, but luckily we can do it recursively. So we can first check the base case. So if the root is null, then we can return null. We don't have to continue. Otherwise, what we're going to do is swap the children. So we're going to save the
Everyone, welcome back. Problem we can left in a temporary variable. Then we're gonna replace the root.left value with root.right, and then we're gonna replace the root.right value with the left value, which we know is now stored in temp. So after we swap the nodes, all we have to do is now recursively invert the subtrees. So we can invert the left subtree, and then we can invert the right subtree. So by doing self.invert tree, what we're doing is making a recursive call to the function we're inside. And once we have swapped the roots children, once we have inverted the left subtree and inverted the right subtree, we know we're finished, so then we can return the root. So there it is. This problem is relatively short code. Depth first search and tree problems in general. Once we have inverted subtree, we know this problem is relatively short code. It's a very good problem to kind of understand the basics of depth first search and tree problems in general. And it's actually a pretty popular problem. And if you weren't able to solve this on your first try, don't feel too bad. Take a look at this trivia. There was a very good engineer who actually failed this problem in their Google interview, but his career still turned out pretty fine. So I hope this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
Baby love.